Hi all, welcome to the session. Hope you're all
Hello,
doing
sir.
well.
Good morning.
Hey Harish, friends, all good morning. Yeah. So we are, of course, every journey should have a destination. Uh, so similarly, our trainings also. But today's specialty is just will be having some allocation of the projects. And apart from that, I thought of giving you some sort of Spark architecture discussion and as well as some of the optimization techniques where we most commonly used. So those things will see, guys. So let me open that objectives. So almost all members have given the names. So I appreciate that. And moreover, this particular project which gives you the confirmation, like we're doing something and we are having some sort of learning in our journey of projects. So in a way, if any such Hive or Scoop or Spark based usage is there, then with the knowledge of Hadoop distributed file system and MapReduce, one can achieve that functionality. Okay, so like that we planned. And in the Spark optimizations, so the idea is simple, guys, like how we are making use of the architecture. So because uh, at the beginning of the session, we have seen some sort of RDDs and data frames. And today also we are going to talk about some of the aspects related to that RDD and data frame. And the basic criteria regarding this understanding of any technology. Maybe if I'm talking about Java, there are classes, objects, constructors, all these things would be there. But whereas in Python, we are having the list, tuple, all these dictionaries, all these kind of data structures. Now, by the way, just if you want to have certain aspects, 1 minute, guys, where you want to get the Python orientation, just let me share that link with you guys because some of the members are having the Java background. That's perfectly all right. But only the thing is, there exists some sort of Python videos also. So what I will do is just let me share this Python common in your free time and according to your requirement. Okay, so just you can make use of this thing. Like, yes, let me paste here. Okay, which is giving you some observation of. Okay, so which is containing the specification of uh, all the basics, like starting from the Python installation and all these things. Let me share that also so that you can have a look on that. I will say. Yeah. So here, just if you refer the Python comment, this is the one I have shared with you guys. So initially, just to go through the Python, whatever the course coverage we are doing, just how I have floated the appropriate syllabus related to this also we are having. And coming to the day one syllabus, all the presentations and all these things, how to download and install Python idle and as well as Anaconda because Python idle sometimes where if I want to perform some kind of command based activities, then I can make use of that one. And of course, snippets. Friends, my strong suggestion would be no matter whether you are learning Hadoop or Python or big data or Spark, try to install the software and perform the appropriate activities. Always, in our school days also, while learning maths and all the other things, people suggested rather than reading, try to practice. Initially, practice our mind won't accept, so it always try to escape. But if we can do, obviously, maths and computer science knowledge is same, guys. Because maths are one after another. After solving some problems, again we'll be getting encouraging, and many a times, which gives some pleasure, which gives some confidence to us. Similarly, here also, whatever the programming knowledge we are having, that particular knowledge helps us. Okay, so to get confirmation and confidence. Okay, programming only coding. Okay, all the things you can do by heart only, guys. It's not like uh, by hurting, or it won't help you. Okay, and moreover, one good news is you need not reinvent the wheel. You need not research on the constructs. You can pick up from anywhere. Code is available everywhere. So, but only the thing is, according to your requirement, how do you handle that thing? How do you make use of that convention? So that is the major aspect. So uh, we are always ready from Indian Academy. So like we'll be floating some of the courses in the coming future also. So like DSA, data structures and algorithms, and machine learning algorithms, classification and regressions at one side, and then unsupervised learning as a short-term courses. Maybe dedicating 3 hours might be difficult for a member who is involving in the project, but still you are almost all members are attending greater than 90% of the attendance, which is very good. Okay, so these initially identifiers and then goes on. Just we'll be talking about the all these conditional statements and all, and just I'm walking through. So just we are having the functions which are very helpful in the observation or implementing of the code. And thereafter, fourth, so just we'll be having the database operations, file operations, and we are having the SQLite frames actually. So that SQLite is built-in database with Python, which is very much helpful to us. And all these file concepts, modules, all those kind of things we can see as a day four activity. And day five, just it will give the fundamentals of the data structures. Okay, as without the list or without the dictionary or tuple or set, um, most of the implementations or logics we cannot perform. So even in our Spark also, many a times we are dependent on list, tuple, or dictionary while creating the kind of source. So what we have done is just we have picked up some employee details in the yesterday's session also. Just we are trying to portray those particular details into the corresponding data frame, and in such a way that pandas data frame we have created, and in a way as a connector, as a pipeline kind of thing, we are performing the same. Okay, the kind of the activity, and thereafter, after completion of this thing, just we'll be having the object-oriented programming. So, which is of course the usage of the classes, constructors, all these things we have covered in day 6 times. And in day seven, so just we're having the NumPy, which is the basis for data science and machine learning kind of things. Because this Python is a general purpose language. At the same time, it can be used for specific purpose also. Like we are having some numerical Python where all the statistical and numerical kind of the calculations can be done. So here the usage of the arrays and all those optimization techniques will be available. And in day eight, the pandas. So the most frequently used uh, package after NumPy is pandas actually. So this pandas is providing the series and as well as the data frame. So just data frame, however, you are familiar, is a table kind of structure which is handling row and column wise data. So based on that particular convention, you can perform the flexible computing. Okay, so that is day 8, and we are having as usual the projects also. This data frame additional kind of the content, and then visualizations are there, guys. Actually, so in day 10 we are having further data frames because data frames provides plenty of functionalities. Okay, all those group by, and yesterday we have seen some of the aspects. Similarly, here also we are having, and likewise, NumPy and Pandas usage, again, some kind of the case studies, and thereafter, just will be having the data pre-processing friends. So, which is pretty helpful for every data scientist or machine learning engineer. The point here is, suppose if I'm fetching the data from Twitter or Amazon, the data comes in all the shapes. Okay, data is having some missing values and it may be having some special characters, which is not exactly suitable to our algorithm or submission to our algorithm or model. So we need to perform some pre-processing. Those techniques we have seen here. So like how we are making use of a convention, all these representations you can specify, right? Okay. And likewise, I am having, as said earlier, so just we are having some capstone projects. So you can see here multiple projects are there along with the data sets. The general convention, guys. So I'll be now also whichever the projects we're having for 7 teams. I have created the projects. All those projects are containing some uh, data sets. They require some data set. I'll paste the data set according to your requirement. It's not mandatory to use the data set specified by me, and it is your creativity and it is your wish. Whichever the data set you feel, I want to implement my task on this kind of the data set, you are free to use that. Friends. There is no restriction on that. Okay. So just these are all submissions also, because these things will give you some idea what they have done and how they have submitted the earlier batches and all. Maybe it is definitely helping you because these are all solutions things actually. Okay, directly don't go to the solutions. First, you try to implement in your own way, and whenever you want to perform some kind of additional operations, or if you want to need some clarifications, then you can go and see this all these kind of things. Okay, so like documentation is there. Okay, all these kind of the evidential templates you can make use of them. Okay, so this is how you can see and learning of Python. Don't worry, friends. The Spark can be implemented with PySpark or Spark SQL. But my strong recommendation is at least you complete data structures in Python and NumPy and Pandas. Okay. So obviously, remaining loops, object-oriented functions, more or less, you are having some other programming knowledge. So definitely, it's not a big difference of identifying or learning those kind of things. Okay, that is how you proceed. So that is the first thing I want to address. And coming to the next aspect, so just will see the objectives of the session, how exactly we will go in today's thing. The objectives, just will see the high level Spark architecture, and then certain optimization techniques we're having. So these optimization techniques initially will see Spark SQL and repartition and coalesce property. And we are having some user defined functions, UDF, and Redefine function. After that, we're having the broadcast variable and caching. Okay, so these things will give pretty simple, friends. On top of our data frame and RDD, we are going to venture all these optimizations. Many more are there, but I want to give a preview of most commonly used optimizations in the industry, and of course, project allocation, the batches who has given the consent. Just I will be giving the allocation of the project, and generally the members will be given some weekdays of the time. Okay, if it is not required, if it is not enough, then we'll discuss. Okay, initially we'll see maybe next Friday, the day. Okay, just will be allocated. 7 batches are there. No? At least 30 to 40 minutes will be required for each batch. So that we'll reserve that day from 10 to 5. Okay, so that we can complete the assessment too. I'll ask Deepika to share the invite. So accordingly, um, you can practice and present the appropriate things, right? Okay. So now, first Spark architecture. So for this particular thing, let me get some information for us. So this architecture, if you observe this Spark representation, friends, this is definitely not new for us, and we have been talking about many things from beginning of this Spark. So, and in the initial discussion we had, like how Hadoop is providing some functionality to the Spark, and Spark how it helps the usage of to empower the Hadoop distributed file system. These things we have seen. Here, the main important consideration is we should understand the uh, whatever the which are all the main components of this Spark. So just we'll try to see that. And moreover, guys, here Spark implementation is running on top of multi-layered architecture. So that multi-layered architecture specifies that maybe initially I'm having the standalone. Okay, Spark can launch on standalone, or I can launch on Mesos, so which is default cluster management tool of Spark, or else I can run on top of Air. Okay, so we have seen standalone Air and as well as the local. Okay, with the support of the Spark, by just submitting the Spark job, we observed that. In two ways, I can achieve the Spark functionality, friends. Okay, one is through the web shell, another is through the Jupyter Hub. Jupyter Hub, and now we are practicing on top of the database. This is also one of the best platform to venture the Spark implementation. Through this web shell, we are having this Spark submit, and we'll be giving that master. Initially, we have given add, or you can give this Spark, or else you can give the local. Okay, either of these. And in the Jupyter Hub also or database also, you can specify master of app in the creation of this Spark reference. So majority of times we'll be using these things because at many the users who are very much interested in the command, still some users would be there, friends. Like especially the members who are having the background of the Linux or Unix shell script. They prefer to write the codes, and it is very it's very beautiful to see such kind of the coding guys where they can write all the commands and they want to submit their jobs. It's their strength actually. But we'll try to see the alternatives rather than writing the entire code. We want to use some API calls. Then in that case, just the most frequently used constructs. Suppose on top of the AWS, if you are launching the cluster, then you can go with the Jupyter Hub, or else Google Collaborator is there, where you need to integrate externally the Spark engine by just installing the Spark pip install kind of thing. Whereas if you refer this Databricks, it's a built-in package, friends, built-in with PySpark, or else you can use the Scala, or else you can use this SQL or R program. Either of these particular languages you can directly perform in the Databricks. So now, if you observe the Spark, this I have taken from the Apache Spark website, guys. To run on a cluster, the Spark context can connect to several types of cluster managers, either Spark's own standalone cluster, or else Mesos, Air, or Kubernetes. This is also one of the best path where you can venture, you can make use of job submissions and all. So the first important point is your Spark context. Friends, here the point is no matter whether you are using the Spark session or Hive context or SQL context, everything the entry point is Spark context only. Okay, so this cluster. Okay, the Spark context can connect with the appropriate cluster, whatever the cluster I'm having. Maybe as I said, maybe that is the ARM cluster, Mesos, or else Air, this a standalone cluster which is having Spark is having its own standalone cluster. All these kind of the things. Okay, which allocate resources across applications. This cluster manager is responsible to allocate the resource. Resource friends here, while dealing with the Databricks also, it is providing us some CPU capacity and at the same time some memory to run our jobs. So whichever the platform providing us the timing and as well as the space kind of the things, that itself says the kind of the cluster, okay, kind of the resource allocator. And once connected, Spark acquire executors or nodes in the cluster. See here, initially, this is the first phase print actually. So the first phase is Spark context connect with the cluster manager, and then cluster manager allocates okay the appropriate resources to the corresponding job. So here the driver program is nothing but our code where the logic which I want to implement. Maybe that is the word count logic, or else the data frame join operation, or else group by key, whichever the operation I'm performing. So that belongs to the category of this logic or coding. Okay, based on the requirement, the cluster manager is going to allocate the task, the appropriate space and time. Now you see here, once connected, Spark acquire executors are nodes in the cluster, which are processes that run computations and store data for your application. So suppose I'm having some application. My application is split into initially guys, there are certain terminologies. Job split into the stages, and this stage again split into the tasks. In the DAG also we have seen, so just it is performing all the activities, just it is staging all the actions or transformations, and whenever the completion completed the task completion is achieved, then only it is going to put the result back to the Spark context. So until that, just it is assigning all the jobs to the corresponding worker nodes, and there are certain communications between worker nodes while sharing or while performing some kind of the activity. Next, it sends your application code by jar or some kind of the Python file, pass it to the Spark context. Jar, why how they are saying is that if you refer the Scala or Java based kind of thing, they are working on top of this jar files only. They are JVM based languages, of course. Okay, but whereas if you are working with the PySpark, there is no context of the jar. So in terms of Python, just the appropriate information will be executed. Okay, and finally Spark context and task to the executors to run. So just this particular Spark context is aware of which are all the tasks are there, because this cluster manager is supporting the entire storage and as well as the process mechanism. So obviously you can achieve the appropriate placeholders so as to execute or so as to complete the tasks. So this is how the kind of the establishment. So we have seen second thing. Now the third point, establish the communication between the executor and as well as the Spark context. Once this is over, again, just the final submission, final. Actually, this is also the third thing. Is a two-way communication. If you observe, Spark context contacts with the executor so as to make sure that whether the task is allocated or the space is allocated or not. And once that thing is over, again. After completion of the task, just you can see here. Finally, Spark context send task to the executors to run. Okay, once that execution is performed, then Spark context convey the information about the job completion or the result. Because in the program itself, the developer want to get the outcome. Okay, so this understanding, but now it is become very easy for us guys because we know Spark context, we know cluster manager, and executor, and yet to see cache actually. Cache I'm going to discuss because the caching and persistence is the default property supported by Spark in the corresponding Spark engine. Okay, so the additional details. Okay, just you can get these particular things. Let me paste this thing, guys, with you. Just you can use these specifications where you can manage, where you can get all the details. And moreover, if you refer, what I am talking about is just let me share that also. Let me walk through this I am talking about. So cluster mode, which are all the only as I said, friends, only two blocks you have to believe. Okay, so authentication I am talking. One is the Databricks. Okay, with the Databricks kind of thing, you will be getting more information. Okay, where they are the members who originated the Spark development and all. Second thing is Apache Spark. These are also official placeholders where you can perform the activity of the Spark and all. Okay, because they are releasing the open source kind of the things continuously, starting from the Hadoop, all these kind of ecosystem tools. They are the one who maintains all the research and all the releases. Okay, so just to go through these, maybe some of the blocks you might feel simple, but however, they need to extract and go see that whether they reference in these two websites or not. But learning the hard way is always better, friends, because however we are going to have some understanding of the Spark, and you should be in a position to implement these projects up to that level. You should be. Then in that case, better to go in a hard way rather than a simple and um, uh, authentication is always important, friends, whenever you are learning that any technology. So that Apache or Databricks, these two I am strongly suggesting. Now, again, some other useful aspects. So just as a task, you can see, friends, more or less what we have seen is the earlier kind of thing in the earlier discussions, okay, we would have done some of the aspects related to this. Okay, so coming to this first example, let me take the first statement about the several useful things to note about this architecture. Each application gets its own executor process, of course, which stay up for the duration of the whole application and run tasks in multiple threads. The thread is a simple thing where in a program, if I'm having the multiple paths, in a simple example, if you are opening your Word document and you are typing something, and immediately you will be getting some red colored underline symbols, and where if you type spelling wrongly, okay, the typing is one thread and spell check is another thread. And moreover, if you want to print that particular document, and some people are assume that that is a distributed file where one common location is there and where you can access the appropriate file. So these are all multiple threads actually. The same application, I have opened that MS Word, and the same application is giving these many paths in that. Okay, this has benefit of isolating application from each other on both the scheduling side and executor side. Okay, it is availability. Okay, basically the application should be available for all the members. However, it also means that data cannot be shared across different Spark applications without writing it to an external storage system. The point here is, guys, suppose I'm just now I have shared the Python common course with you. Actually, the course is in my OneDrive, and if I'm sharing and if I'm putting you guys to access that particular thing, then only it is possible to access the data or process that thing. Why we are doing all these things is we need some of your suggestions also, guys. Maybe like I have floated some SQL course and advanced SQL, and then Python we have covered, and now we are doing these big data tools. And parallelly, I'm running that Databricks machine learning and data engineering. Like we are having plenty of the resources with us. And apart from that, if you need any additional support, like data structures and algorithms, nowadays clients are also focusing on those things. Or if you need any specific, some two or three sessions, like on classification or something like that. Okay, whichever you feel that I need this particular training, or if I'm getting at least 10 or 15 nominations from the manager, definitely we can float that in a way. Once I record those kind of thing, it can be shared across the different views. Our aim is to empower you guys and don't stop with your technology or core competency. Core competency is definitely important, but apart from that, try to learn one another or one different technology. So because the projects we are getting in machine learning and Python and SQL is of course obviously common in every project, in every client. So be strong in those two things, and I am sure that if you are having the Spark knowledge, and at least if you are doing this, whatever the project I am sharing, definitely you are in a position to capture the upcoming projects. Okay, without any doubt. So just we can go through these things, friends, and clusters. Of course, multiple clusters are there, and if you want to study more, Hadoop and however we have seen, but apart from those Hadoop and if you want to know much about these kind of things, you can have a look on this. Okay, these are all further discussions related to the architecture. Okay, now let me start with the other genre here, maybe just let me start with Spark SQL, friends, actually. So out of time, interest of the time, so just I already used these particular implemented for the sake of the demonstration, so that we are having many things to cover. So that I thought of giving you the ready-made scripts for you, and we'll walk through these kind of the things. Okay, and many of the statements already we have seen, but only whenever there is a requirement of iteration, definitely we can see that, right? Okay, and you might have observed this entire thing is related to the Databricks, and we are from past 2 days we are enjoying our coding with Databricks only. In a way, it is providing a good environment, and I have created a cluster. So already I have shown you. So just you can go to the create and click on this cluster. Then just only the thing is you need to give the name of the appropriate cluster. Okay. Then the cluster, as just now also we have seen the kind of the cluster manager which provides the resources to the Spark. Now, in this Databricks, friends, one point already we observed, that is, you can either use the Spark directly, this thing, without using the Spark session and all. But whereas if you are provided with AWS or Cloudera Manager kind of thing, they are not native of this Spark. Spark. Because if you see this Databricks, of course, everything in the Databricks revolving around the Spark technology only, so that they maintain this SC and Spark as a default references, where the same is not true in AWS and Cloudera Manager. So our learning must be in a generic way. Once you start applying the thought, or once you start implementing the projects on any of the tool, you should not be feel that, oh, this guy has not covered this. Okay, you should not feel that. Okay, so that is the reason why we are making use of this thing, and majority of our functions, majority of our modules are available with PySpark.SQL. Okay, this is the one where you can get all your conventions related to this thing, right? Okay. And here, of course, this is a pretty old statement for us. Just we are creating a reference of this app name. Okay. Now, what we are doing here is this is a list of tuples print actually. Okay. This these kind of brackets belongs to the tuple actually. So just I'm creating a list here. And then, as usual, one important statement I want to give to you guys. Just this particular thing, what it does is, so if I'm making use of this thing, okay, let me uh, show you here in the because we don't know when we are using some kind of the data, what is the schema of that particular data. So let me give you this convention, what exactly, because this is most important whenever I am loading some data from the external source. See here, as of now, what we have done is df emp spark dot create data frame. Earlier we have used frequently pd dot data frame of some kind of employee details. Okay, this is the way we are using the data frame creation. Just a little change in this guys. And moreover, apart from these things, we're having various forms of creation of the data frame. Data frame can be created by list, can be created by tuple, can be created by dictionary. Even with RDD also, you can create, and with the pandas also. These are all plenty of ways where you can create your data frame. Now the point is, suppose I want to specify my data frame in such a way that, so I want to use some column information, name and as well as the age. Okay, of course, without this also you can mention, but always it is a good or best practice so as to mention the schema. So the schema is nothing but the design of the data frame, like how we defined our schema in databases. The overall design of the database is nothing but the schema. Similarly, here also we are having the schema. The schema is nothing but the design of the data frame. I am specifying that I am using name and age as the attributes or columns in this particular data frame. Okay, so that's simple, friends. Okay, this is the argument which gives the information about what exactly our detail or data is there and how we are performing the activity related to that convention. Okay, so with this, just what we are doing is we are creating a data frame, and up to this pretty common. So whatever the functionality I have used, the same way of functionality here also we are performing. Okay, so create data frame. Just I am mentioning my data as the list, whatever the list I am having, and then my schema. So what exactly the kind of the details I want to mention, that is the name and age. Now you see nothing different, friends. If you observe the earlier thing, df underscore emp spark dot create data frame of list one will give, and obviously it is going to create this way. Okay, and now what we are doing is we are explicitly mentioning this name and age, because we are not mentioning any names here. Okay, but I want to specify name and age in a clear cut way. Then whenever the new developer comes here, he can feel that, oh, this guy is using this data with the two columns, and the names of the columns also if you give, then it automatically gives the understanding of what we are doing. Okay. Up to this, we are common. We have done earlier also. Again, we are taking one more list. This list is like it is containing the name, and we don't know the second argument. So clearly, if you see in this representation, I am mentioning that my first argument or first item is the name, and my second thing is the department number. Okay, just we are making use of 101, 102, 103, 105. Like that, I'm having some sort of the department numbers. Okay, so data we are mentioning at the same time we are mentioning the schema also. Now, name and department number. So far we have created two data frames. One is the employee data frame, and another is the department data frame. Up to now, pretty common. And now the point is that here, friends, the Spark SQL or any SQL kind of the construct definitely requires some kind of the table. Okay, so on top of the table only, once you create the table, then only there is a possibility of insert, update, delete, or whatever the operations I want to do, performing the correlated subqueries or subqueries, whichever. So all these kind of the conventions are possible only through the relation or only through the table. In Spark SQL also, the same convention we have to follow. What we are doing is already we are having the employee data frame with us. And what we are doing, there is one option called create or replace temp view. Observe guys here. Yeah, on top of the data frame, and if you want to apply or if you want to use your Spark SQL and in the programming, you want to perform some kind of the Spark SQL based kind of the implementation, the first and foremost requirement is from the data frame, you need to create the table actually, table or view, whichever. So for that, we're having related to this data frame, I'm having this statement, create or replace temp view, create or replace temp view. In the generic sense, friends, create or replace index, create or replace view. The same way, if the view is not there or if the table is not there, create. If the table is already there, then you replace that. Okay, because here itself we are clarifying. I don't want to preserve the earlier thing. Just I want to specify whatever the data item I'm having. Just you give the data item or create the data item. If it is there, overwrite it. If it is not there, create it. Now you see, guys, this EMP is something like which I can use to make use of the Spark SQL kind of the statements. Okay, so the connection is very simple. First, we are having some data frame, maybe ready-made data frame I'm having, or else we can create the data frame, and that data frame can be converted into the uh, appropriate relation or table. Now this EMP, I can make use as to apply the Spark-based kind of the command set. Okay, now you observe guys here, spark.sql, spark.sql, select star from EMP, where name equal to power. So called employee, just I want to pick up that employee information, and this show and all remains same. Now this see friends here the exact the syntax if you observe select star from table where some condition how you are performing your in your SQL the same way you can achieve the convention in Spark SQL. Only the thing is you need to instruct that in the earlier thing directly I can use the df underscore emp dot select. Yesterday we have seen some of the transformations and accordingly you can use the select statement and all. But whereas here directly, what I'm doing here is directly I'm mentioning that spark.sql. Okay, just I'm mentioning the spark.sql and we are making use of the statement. This is a direct SQL statement. And so this SQL statement picks up the data and then is a typical how we are using in our data frame. Definitely we have to use the show method. Okay, so this is how you can perform. And in the second way, already we are having the department data frame. Now again, I am creating create or replace temp view, and I am naming that view as department. Then I can say select star from DEPT where department number equal to 105. Okay. But remember that I should instruct the Spark clearly. I'm using the Spark SQL, Spark.SQL. Okay, Spark.SQL, and you give the appropriate whatever the statement I'm having. Select star from DEPT where department I'm equal to 105, and you can pick up the results. Okay, these are all pretty simple statements, and if you want to leverage or if you want to continue with your SQL kind of the capabilities, absolutely you can perform that, friends. Okay, now let me see this. Sometimes there is a possibility of converting the table into the data frame. Okay, that thing also you should know now, because maybe a new guy came to our team, and he's very familiar with the PySpark only. He is not having that much capability of doing Spark SQL. Then what we should do? Just we need to give that table whatever I'm having to data frame. Then how do I convert that? Just a simple analogy. Df emp tab equal to spark.table emp. Then obviously this table whatever I'm having will be given back to the data frame. Okay, so spark.table emp, just it will be assigned to the data frame. So uh, indirectly, friends, what we are doing is first we have taken the data frame. On top of that, we have established that emp. Assume that directly we are having some view or table. Okay, already long back we have created some kind of the view on top of a data frame. We habituated to use that particular SQL construct only, that EMP view only. But later point of time, again due to some of the members want to implement their task in PySpark, then what should we do? We have to convert that employee table into the data frame. Now onwards, just simply no need of Spark.SQL. Directly, I can perform the activities how I am doing with my data frame. Okay, so there is a distinction. If I want to pick up the rows from the view or from the table with the help of the Spark SQL, the very prefixed statement is spark.sql, and use the SQL syntax here, SQL way of picking up the data, select star from EMP and all, and you can show the appropriate records. Whereas in the data frame, we pretty know directly data frame dot show, which gives the outcome of the data. This is the way. And yes, some other important points are there, friends. Like it's not always possible, or it's not always required to create our own data. So far, we have used some kind of the employee details, and from that we have created the data frame. Sometimes our data might be in Excel or in the CSV format and all these kind of things. Now, what you can observe here is just first I need to convey, because in Jupyter Notebook you are all knowing that either I can especially in our cluster, so just either we can load the data through the WinSCP, or else you can load your data from Hadoop distributed file system. Okay, so from HDFS you can load directly to login portal and you can pick up the data. Likewise, we have done. But this is a platform which is not at all connected with the local file system or HDFS. It is having its own cluster. Okay, we are running on practice 9 cluster, and this Databricks is a built-in Spark SQL supporter, Python it is supporting, and you see here the many languages it is having. Okay, so Python, SQL, Scala, or like that I'm having. Now the point is, how do I load my data into this particular platform? Okay, so pretty simple. Just whatever the content I'm having. So just you can go to this workspace, friends. Um, just you can click on this, and with respect to this workspace, if I want to import something, okay, import some file, okay, maybe the source ipynb file or databricks file, whichever, but my requirement is I want to upload the data into my workspace. So just you can click on the data, and it is giving some kind of the interface, friends. Okay, just to create table. Okay, now you can see many options: upload file, S3, DBFS, other data sources like that. Okay, so here other data source in the sense maybe Snowflake, MongoDB, Redis, Kafka. JDBC, like that I'm having many sources are there. My requirement is I want to upload a file from my machine. Now you observe here, guys, while uploading a file into our Databricks platform, just it is giving the Databricks file system target directory. Okay. So what it does is just this DBFS is a Databricks file system. It provides a simple place to put data in Databricks. New folder can be created by entering a new path in the text box. So here, if you want to create a new folder, maybe like I want to create some folder and I want to create a new file. Okay, then I can do that. But my requirement is just I want to pick up the appropriate file into my storage. So what I want to do is just to click here. It will be allowing you some sort of information. Okay, and just I want to either I can upload the data. Okay, just if you are referencing the just in the desktop, I kept that data set and some of the data set and maybe sales info. Already orders I have placed. Now let I want to show you how I am loading this data. Sales info. Now do not do anything, guys. Okay, no problem. Do not do anything. Just to go to the DBFS. Okay, after that, no need to create any table or something. Your file is successfully uploaded to this path actually. You see here, file store, tables, sales info, like same path you have to use. Maybe even I am using the sales underscore info, our Databricks has given some other name actually, sales underscore info hyphen 2. Okay, this name I should use in the reference. Now, what it is saying, your file has been uploaded to this particular path. Let us confirm that. Sorry. What I'm doing here is just I should go back to this data once again, and I should select not upload all the file has been uploaded. Just to click on this. Now file store. There is a tables. Now just now we have inserted uploaded this thing the sales info to this one actually. Okay, so likewise, I uploaded this orders one table page. So as to refer this particular path, I should specify my file store slash tables slash orders one because this is the default directory provided by our database. So as to upload our file and I can apply some kind of logic on that particular file. Okay, once your file is available into our location or in our workspace, you can perform any activity, friends. You can perform any kind of the activity. Now, let me go back. So here, recents, I'm talking about this thing. Again, I want to go back to this convention. Now, I'm having this file with me. So I want to load this thing as said earlier. Okay, just this is a path, whatever the path I just shown to you, like file store slash table slash the corresponding orders information. And the other option is just I'm mentioning the format as CSV. Like that I'm having JSON, Parquet, Avro, many kind of things are there. Okay. Now, how do I read that data? Just there is a convention spark.read.load. Just I want to load some kind of the file with the specified format. I can do that. And now, friends, here, like how I am performing the take of 5 or take of 10. Similarly, in the show method also, because this orders file is containing many rows. It's a huge file. So I don't want to pull up all those kind of the details. Just I want to mention a few records for the observation. Maybe the first one is containing some timestamp information, second and third. Okay, right. This is the order relevant data. This is order ID and as well as whether that is order delivery is closed or pending or complete, some kind of the status information. Okay, so as usual, after loading of the data, this behaves like a data frame and whatever the functionality I'm having tagged with the data frame, I can make use of that functionality without any deviation. Now, this print schema, what is saying, friends, though I'm having the second thing as a number and first thing as a timestamp, it is storing everything as a string. It is storing everything as a string because directly I'm loading the file and just I have mentioned this format and I'm not mentioning any schema orientation. Now, how do I do that is just there is one more option called infer schema. Okay, most important thing, friends, because suppose client is giving us some kind of the input file in the format of the CSV. Now we exactly not having any clue or any idea about what exactly the data, what is the data type, what is the format, and all the things we don't know. So then we are inspecting our Spark, like you can follow up the schema which is provided by the source data. Okay, whatever the data I'm loading here, okay, according to your understanding, just you info the schema. Okay, infer schema in the sense whatever the file I am uploading, and that while uploading that particular file, I want to specify instruct Spark to decide about the schema information. So that infer schema we are mentioning. And see here, earlier I'm having certain disturbance here. Now, you see, directly all the details I'm getting. Apart from that, if I'm printing the schema after this infer schema is true, see, accordingly, first thing is the integer, second is the timestamp, third is the integer, fourth one is the string. Because in the earlier case, all becomes string kind of the things, which is exactly logically correct. Of course, numbers also can be represented as a string kind of the data. But if any person, if any developer want to apply some kind of the mathematical or statistical functions, again he has to convert that string into the number format. Of course, we can do anything with logic frames. Okay, there is no restriction on that. But the simplifying at the source is always the best option. Rather, with the programmatical techniques, if it is any, if there is any possibility of doing that thing at origin, maybe rather than changing temporarily, it is always better to notify the appropriate convention at the table level or data frame level. Okay, it's a simple analogy where you can load and process your data. Of course, if I want to import some kind of the details from external, suppose I will be sharing these things, and how do we open this? Okay, just you can go to the workspace, and you can manage this import friends, and here you can browse. Okay, there are certain aspects. Um, I am maintaining all our files in this thing, and okay, so just I'm talking about Spark SQL, na? Just select open, and it is, you can import this. Okay, that's all. Okay, so two possibilities, friends. Don't get confused. One is importing of the data. Data directly you click on this data, and it supports some create table option, and accordingly you go to your upload, and here browse accordingly just to select that particular option. This is one thing. Whereas in case of the workspace, okay, so you need to mention this import and then browse, select the corresponding file. So these two options. One is the import of the data, another is the import of the uh, file. Okay, whatever the source file we're having, so as to practice. This is pretty simple. Like how do I maintain? Okay, so let me record this thing in the OneNote so that we can have a look on that. Here itself we can complete the key takeaways so that we can move to the next topic. So coming to the second option, what we have observed is Spark SQL. What we have done, guys, just we have created a data frame, and then on top of this data frame, create or replace temp view of df1. Now onwards, what you can do, spark dot SQL, select star from df1 dot show. Just you can manage that kind of the convention. Similarly, again, if I want to convert this df1, what should I do, guys? Df1 underscore data frame equal to uh, df1 dot table of df1. So just we are going to refer back the appropriate information. So this is how you are maintaining the Spark SQL, and all the operations are as usual. Third option is loading of the data. Load the data from external source. Data I'm talking about. So for that, select the panel of the data bricks, and here I am having the menu item as data. If you click on this particular data, we'll be reached to various placeholders, upload file, S3, DBFS, like this I'm having. Now you select the upload file. Here browse option would be there. Okay, so click on this browse, and which will be leading to your machine. Okay, I'm selecting this orders file, order one dot something. So just you select this, and obviously what it does is just it will open one more panel. What it says, your file will be stored in file store slash table slash order one. Okay, click on OK. So how do you check this? Just you select DBFS. Within the DBFS, we are having file store. Click on this, you will be go to the table. Again, if you select this table, you will be getting all the files which are available. So this is the way how you can load your data or import your data from external source. Next thing is how do I import a .ipynb file? Okay, so for this, just I need to have the workspace, and after selection of workspace, you will be having some user info. Select this drop down. Here we'll be getting multiple options. Select the import, and from this import, and it leads to your machine, and there you select SQL example dot ipynb. Automatically after importing, just it will be displaying the appropriate file in the cell format. So this is the way how you can make use of external data loading and as well as the external source data loading. So this is how you can refer the convention files. Okay, pretty simple. And only the thing is, while learning the core part, then only there is a suffering. Once you are completed the fundamentals and understanding of those constructs, our life becomes easier. Okay, right. So this Spark SQL kind of thing, and thereafter the other convention before creation consists. Let me talk about some other simple. Yeah, repartition also dependent. I talk. Hmm. Let me talk about the UDFs because the similar kind of the convention we are using. UDF is something like which is a user-defined function. According to the requirement of the user, he can make use of that UDF usage. Okay. So same thing, just we'll be getting the Spark session information from PySpark.sql. Just we are importing the Spark session, and we are giving the name of the app as UDF with Spark SQL, and the entire reference is maintained with the Spark. What we're doing here is, there are certain types provided by Spark, actual integer type, string type, double type. Like that, we're having some data types. These are all nothing but the data types. So what I'm doing here is at the time of creating some functions or user-defined functions, I may want to refer some data types, maybe integer, string, float, or all these kind of things, so that I am importing that particular types into my workspace. Now, to implement the user-defined functions, there exists some kind of the import statements. This is PySpark.SQL.functions. Earlier, if you remember, guys, our concat, COL, and one more thing is there, LIT. All these three we have imported from PySpark.SQL.functions. Okay, just what we have done is we are making use of those particular three constructs into our workspace, and then we concatenated first name, last name, and we have used alias, and in between we have used the COL and LIT. Similarly, my user-defined function also exists in PySpark.SQL.functions, and with the help of this reference of the UDF, I can make use of the convention of how I'm performing the implementations. Now my requirement is, friends here, just whenever I am giving the name of the corresponding person, I should display the length of the name. Okay, maybe I can take this scenario where we have collected some data from various sources, and I want to store the data into a table or a data frame. For that, I want to find out the maximum length. Maybe the customers who are having 15 characters in their name or 20 characters in their name. So I want to find out the length of that particular name. So what is your lambda function, friends? A lambda function is something like which is inline function. So rather than wasting the time on calling the function and carrying the arguments to the appropriate location, it is always to perform the activity at the same line. That is what we call the inline function. So those kind of the functions are known as the lambda functions. Now what we are doing here is even in our map or in flat map, in all those kind of the cases, we have used the lambda function. Okay, because it is quite handy while working with various kinds of the um, uh, uh, transformations and as well as the actions. Now here also, as I want to create the UDF, I am creating a UDF, and this UDF is referenced by ESLen. What does this SLen means is whatever the logic I am implementing with the user defined format, now I can achieve with the SLen. Okay, like in this thing also, guys. Now Spark is a combination of Spark session, Spark context is there. It is having the details about this application name. This is a reference. Similarly, what we are doing is that just I am creating a user-defined function, and the reference of that user-defined function is available with the slen. Now onwards, I can use the slen means string length or string length so as to implement the logic. Now, what is my logic here is just have a look on this. Whatever the string I am giving, whatever the argument I am giving, just to return the length of the string. Okay, just to return the length of the string. And the type of the return type, the type of the return value is integer type, because though I am taking the string as an argument, once that string has been sent to the length of this user defined function slen, it is going to return the number of characters, so that the return type must be mentioned, because remember, friends, a function is used to perform a task, and after performing the task it should return some value. Okay, after the completion of that particular task, the function should return some value. So that is the main important aspect. So here we have just created a UDF, and that particular UDF is requiring some string data. And after performing that particular functionality or task, it is going to return some integer. Okay. Now the point is we are having the built-in functions like length, print, or in the earlier session we have seen some actions like the count, take, collect, all these things. But those things are known to the Spark because they are all Spark built-in functions. Now we are talking about the user-defined functions. How this user-defined function is recognized by the Spark? Okay, because Spark may be having some tons of the functions, and we are also creating some sort of the function with the name of user-defined. But how do I convey my user-defined function information to Spark? So for that purpose, we're having a statement called this thing, friends, spark dot udf dot register. Okay, so just I'm registering this name, whatever the name of the function I'm having, yes length. See here, guys, string length, and I'm naming the tag because sometimes maybe the function name is different and this thing may be different. That is all your wish. But to avoid that ambiguity or to avoid that particular confusion, always better to have the same name. Okay, whatever the name you have used to create the UDF, better to use the same name. But only the convention is your SLN, whatever you have taken here, must be put in the double quotes. And now this is referenced by the SLN. Okay, so just what we are doing, we are establishing a UDF kind of the functionality, and then we are registering that particular function, whatever the user-defined function I'm having. Now you see here we are getting the confirmation of yes, this is a lambda function with accepting some kind of the arguments. Now what I'm doing here is, as I said earlier, we are working with the UDF with the Spark SQL. Okay, rather than, of course, you can work with UDF with a normal Spark also, PySpark also. I'll be sharing that document with you guys. In three ways, you can create the user-defined functions. With the help of the Lambda, you can create. With the help of the @UDF, you can create. Or with the help of your normal functionalities, like you can use the looping constraints or whichever, in a more generic way of creating the UDF. All the three different cases I will be sharing with you. Just you can practice accordingly, right? Okay, the same procedure. UDF you have to create and then register the UDF according to the requirement. So now I'm pretty interested to make use of this Spark.SQL. And as I'm not working on any data frame, I need not create any. I need not use any data frame so as to create the view or something like that. Directly, that is the advantage, friends. Directly, either PySpark way or with the help of the Spark SQL, I can apply these functions because the main advantage of the functions is reusability. Whatever the function I have created, and those kind of the functions must be must be available to all the other ways. Like suppose if I'm just now I have created that S length, string length, and the string length should be available for every developer because in fact we have registered with respect to this thing, and of course one point is there guys up to this session only. Whenever I am closing this session or whenever the cluster is stopped, then this SLN is no longer valid. Again, you need to create this UDF and you have to register this. It's not a permanent thing, guys. Every time it will be deleted. Only for this particular session, you can make use of this convention. Okay. Now, what I'm doing here is, guys, SQL running of the data, just a spark.sql, and I am making use of this select. Directly, I'm using the slen, but just you can give the name of appropriate member and then display the details. Okay, whichever the length of that particular length of number of characters in that string, it will be displayed. So this way, the user can create the UDF and he can make use of the UDF in the functionality, and then directly he can apply the appropriate UDF function with respect to Spark SQL. So this is the way how you can perform the logic of achieving the things. And my just I am asking you, just you can make use of this task with respect to data frame also. Okay, not only with the, but it's quite handy using of Spark SQL. But in case of the data frame, again, I have to create a simple data frame and I have to perform. But without data frame, if you want to run through any of the application, then it is the best thing. Okay. Now, what I'm doing here is, guys, as an extension, like as earlier we have created some list. I've also just we have created some list of tuples. This is a tuple representation, a list of tuples, and then we are creating a data frame like my data is list and the schema is name and age. Earlier also we have created. Now we are creating the this view actually. So this I think we have covered, friends. Yeah, no problem. So again, in what way we are using this SLN and all combination. So this from the employee data frame, we are creating the um, Spark SQL kind of the construct. Okay. So for that, already I'm having this employee data frame. On top of that, create or replace temp view. Just I'm naming the view as EMP. Now onwards, you can use the EMP data. So how do I access that data? Spark.sql, select star from EMP and show. And I'm having these names related to the Spark. Okay, so now what I want to do is I want to make use of this predefined function, a user-defined function, along with the normal query. So select rather than selection, I want to apply the projection actually. So spark.sql select name, already name is there, and as well as this time I don't want to get the age details. Rather, I want to embed the user-defined function. So slength of name from employee.show. Now you see, friends, how many users we are having. For all those users, it is going to pick up the appropriate outcome. Okay, so in this way, just you can work out with the specification of user-defined function along with the Spark SQL. And at times, maybe I want to apply this logic to some set of the data items where already I'm having some data frame. And on top of the data frame, it is easy for me to create a view. Because Spark.SQL, if I want to apply, definitely I need some tabular structure. So for that particular purpose, we are making use of this tabular purpose. Okay. So this is how you can see the observation of because after seeing this thing, you may feel that almost similar. PySpark kind of the coding and as well as the Spark SQL almost similar, except that in case of the PySpark directly, I can use the data frame and on top of the data frame, I can apply some kind of the logic. Whereas in terms of our Spark SQL. So just what we should do is we have to maintain a view or table kind of structure. And on top of that, you can apply some SQL constructs so as to pick up the data. So this is the way how you can specify the usage of the user-defined functions. Okay. So let me record this so that you can see the convention, how you can refer. The next topic is the UDF kind of thing. So what we have achieved, let me conclude so that we can move to the next topic. So the user defined function. So for this, we have imported integer type, and again we have imported the UDF actually. We have imported the UDF. And the first step guys here, we have done some string length UDF of some kind of the lambda function I'm taking. A length of s and which is returning the integer type. So in this way, you can perform the logic. Now, this is not ending of the matter. What we need to do, spark dot register dot UDF. This is the next step probably. Just I am using the name of the thing, and I am using the same thing here. Okay. Now, how do I apply this particular length? So for that, simple spark dot SQL select slen of some kind of the name. That's it. So just you directly give this thing. Automatically, it is going to give the details. And in some other way, suppose I'm having a data frame just to create a table called EMP with employee name and age. Okay. And on top of this, you can create the employee view. Then how do I access employee? Uh, Before that, spark.sql select name I want actually, and then I want this slen of name from emp uh, dot show. So in this way, just you can make use of the user defined function either way. So maybe directly you can launch your Spark SQL and you can achieve the functionality, and thereafter you can perform the logic. Okay. Now the most important topic, guys, now the memory orientation. So before launching that example, I want to give you some kind of the understanding of this memory orientation. Uh, this diagram or this thing shows us how we are making use of the convention of various memory possibilities. Let me pick up the details for us, guys, which is very, very handy. And while performing some kind of the activities, it is quite important to observe that memory orientation. Let me copy if I can. Yes. Okay. Have a look on this, guys. Just how do I record these kind of the conventions? Yeah. So how internally Spark is storing the data? We know that uh, Spark stores the data in memory. If you observe, guys, this diagram, it is showing memory only as the default storage because our Spark is popular because of this in-memory computing. In-memory computing. So obviously, if you are talking about the memory orientation, your storage level is um, see here, friends. Many possibilities are there here. If you are storing only disk, the first thing is true. If you are storing a disk only two, that means multiple disks are there. Backup is also there. Then it is becoming two. Multiple disk I am storing both memory and disk. This is of course reference of the disk, and this is reference of the memory. That's what here you see. The second thing is referenced by the memory. First thing is referenced by the disk. Here disk is false, but here disk is true. Second also true. As I am mentioning memory and disk, both first and second arguments are true. Here memory and disk. Okay, this is multi-disk combination. First is however memory. First is however disk. Second is however memory, and these are all false. Those things are also become true, friends, somewhere. So just if you see a heap memory, just the first three becomes true. And whereas if you are referencing some other, all the remaining things are false only. So this serializability, actually, friends, the serializability is a combination where you want to maintain the state of the corresponding file. In general, we won't do that. Okay, the state will be maintained by Spark and of course with the RDD because this itself is having the resiliency, and as well as one more property is lineage actually. Due to that particular property, it is enjoying the benefit of in-memory computing. And if the allocated in-memory or if the allocated RAM is not enough for the processing of the data, then it can make use of the disk. So, in that connection, friends, our requirement is either memory. This is the first thing. Second thing is maybe I can use memory and disk. These two are the possibilities. And as a third combination, I can go with memory and disk backup, like disk two. This possibility is there, no? Memory and disk and memory and disk two. Okay. So just what it refers is just it is providing some sort of bitmap kind of the storage. Um, So in this off heap, I'm storing in memory and I'm storing in the disk and I'm storing in the heap also, heap memory kind of thing. Okay. So except this kind of the combination, okay, in all the ways, only first two are true, remaining all false actually. Okay. So according to this particular notion, I can say that if my first storage level, what do you mean by storage level is which are all the possible combination or the current, whatever the data structure or whatever the value I'm using, whether that value is stored permanently in the disk or it is only memory relevant. And if you want to perform these kind of the activities, so you should come up with some kind of the analogy. That particular analogy is nothing but observe friends, cache and persist. Okay, this thing we need to observe. Okay, so caching we pretty know, friends. Caching is nothing but observe here and having the storage with me, hard disk, and this particular data is loaded into the memory so as to perform some kind of the application or programs. While running the program, the program access the data from RAM, and most frequently accessed data items are stored in the cache actually. So now you see the distance between program and RAM. Distance in the sense the time taken to access the RAM contents. I need to say that not the physical distance, but the taken time taken to pick up the entries from RAM to program. This is time one. Cache memory is nothing but the time taken from cache memory to the program. Now, definitely, guys, this time two is always less than time one. It's a simple equation. The conclusion here is accessing of the cache contents, as cache is nothing but the frequently accessed items info. Okay, RAM is containing the active set. Active set in the sense which are all currently we are activating. What are all the aspects we are having currently? All those particular aspects I am having in my RAM. Whereas the most frequently accessed item will be placed in the cache memory. So always cache memory access took less time when compared with the RAM access. That is the main important thing. And now what we are doing here is suppose if I want to maintain the caching, I have to persist my data. Okay. What do you mean by persist means persistence is a mechanism of keeping the appropriate things into the cache memory. That's the understanding. So cache memory definitely near to the program or code compared with the RAM. RAM, of course, very much near to the program when compared with the hard disk or any external storage. Now, certain points we need to notify guys while dealing with this persistence and as well as the uh, corresponding cache. For that particular purpose, I'm having some data with me. Let me pull that thing. What is that? Because these two should be studied in parallel. The disk storage and as well as the persistent and cache. Now, these are all some of the points. First, let us try to understand these points. One of the most important capabilities in Spark is persist or cache a data set in memory because to avoid the access timing or to maintain the optimizations, just I can make use of the persist or cache. When we persist an RDD, make sure that guys RDD is coming into the picture. As I said, if memory or low level aspects or else Spark context is there, then the suitable construct is RDD. Okay, so we can mark RDD. So this, if you refer the persist RDD, each node stores any partitions of it that it compute in memory and reuse them. Okay, each node stores any partitions, whatever the partitions of it that it computes in memory and reuses them. So this is quite understood. And we can mark an RDD to be persisted using the persist or cache methods on it. The first time it is computed in an action, it will be kept in memory on the nodes. Suppose if I feel that some of the data I may use most frequently because all my teammates are trying to work on the employee data frame. What I can do is I can persist this object into the memory. Then automatically, whenever I want to access this, I need not go to the RAM or hard disk. Directly with the persist or with the cache, I can access the data. In a way, it is reducing the overhead of time and as well as this additional CPU requirement. So Spark's cache is fault tolerant. See here, guys. If any partition of RDD is lost, it will automatically be recomputed using the transformations that originally created. This is the concept of lineage actually. So if any problem is there, because that is the main benefit of our RDD, guys. Though some problem is there with the RDD, it go back and what is the source of creating that particular RDD. It again computes that and it will be fetching that information without any fail. And each persisted RDD can be stored using different storage levels. And the storage levels are just now we have seen. These are all various storage levels. Disk only two, memory and disk two, and memory only. All these kind of the things are nothing but the specification of the storage levels. These levels are set by passing a storage level object. I'll show with the demonstration, friends. Okay, don't worry. But just what I want to convey to you is first you try to observe what do you mean by persist and what do you mean by the storage level. Your persist is a mechanism of instructing the Spark. Just I want this RGD in my cache. That is the first point you have to observe. Your second point is the default storage level is memory only. Just this is the default storage level. But sometimes I can change this to memory and disk. Okay, this is the best combination. After the memory only, memory and disk is another best combination. Okay, just to remember that memory only means only the second option is true. I'll show programmatically how I can establish these kind of the communication. This is one thing. And if your data is memory and disk, then first two statements are true. The first two bit pairs are true. And if you want to maintain memory and disk twice, then in all the other cases, we're having the possibility as one. Only one time we are storing in memory. Only one time we are storing memory and disk. Whereas if a replication is there, if multiple times I am storing in the disk or one time memory and multiple time disk, then it becomes two friends. Just have a look on that. So that means if I'm having one means only one copy I'm maintaining. If it is replicating, these two. Okay, only two times it is allowing, not three, because in Hadoop we are having three different possible combinations. Okay, so this is, I think, these inputs are enough. Let me go back. If any other points I need to discuss, guys, just a minute, because these persistence and cache are pretty simple to understand. Um, okay, that is enough, guys, and we are good to go to our data bricks. Let me share the thing. So it is enough to have the discussion. So where is our yeah? What we have done so far is just we have completed the PDF kind of thing. Uh, now, one minute, guys. PDF I have seen. UDF this thing. Spark SQL we have seen. Repartition and coalesce. Broadcast I'll talk later. Now have a look on this, guys. And one more important thing is um, what do you mean by repartition and as well as the coalesce property? So I forgot to mention one important distinction I should maintain here, guys. Just a minute, uh, because this is also one of the important criteria to understand because these are all connected in nature. It is enough to observe one more concept called repartition and as well as the uh, coalesce. Just let me pick up those details also. 1 minute, guys. I'm compiling that aspect, and then 1 minute. And there is a coalesce. Just I'm making use of that convention. Coalesce I'm picking up. Sorry for the delay, guys. Yes. Okay. Simple. With the diagrammatical representation, we can make use of that process. This is how you can refer your repartition. Okay. Why do I need the repartition? Two reasons, friends. Suppose my whatever the data I'm having, the data is only the by default I'm having two partition, but I'm having many a large data set I'm having. So as to improve the parallel, maybe I can increase this partition to 10. That is one possibility. Okay, so your default partitions are only two. So as to achieve the parallelism in a better way, because these partitions are helping us to map the data and to store the data and to process the data. So having number of partitions according to the demand of the data definitely gives the better performance. Other way is I'm having more number of partitions, but my after filtering I'm having only 10 records, and storing 10 records in these many partitions is definitely a space wastage, and it's not optimized way of doing the thing. So I can reduce the number of partitions. Okay, either I can increase the number of partitions or else I can reduce the number of partitions. Okay. Uh, Now, friends, here, if I want to increase or decrease the partitions, I can use the repartition, because the problem here is repartition uses the concept of the shuffle. Yes. Okay. In the earlier session also, we have used the narrow and wide transformations. In narrow transformation, I don't have any shuffling. Okay, directly appropriate partition will be mapped to the uh, output, and it is going to generate the outcome. Whereas your shuffle, especially the wide transformation like joins, distinct, if I'm using, then obviously there is a shuffling in the corresponding input data so as to generate the outcome. In the same way, but what is the problem with the shuffling? Shuffling, what it does is it is incurring additional space and time requirements. Okay, so your shuffle is keeping some extra resource access in the cluster management. Okay, so that is the thing. So the repartition, maybe if I'm increasing the number of partitions or decreasing the number of partitions, in both the ways, in both cases, shuffle need to take place. Okay, whereas the other possibility is coalesce property. What do you mean by coalesce is no shuffle in coalesce. What it refers, guys, generally, general thumb rule is suppose I'm having the 100 partitions. I don't want these many partitions. I want to reduce the partitions. Remember, friends, coalesce only supports reduction of the partitions, not the increase of the partition. If I want to reduce the number of partitions, then only go with the coalesce property. And once you reduce the appropriate number of partitions, coalesce is not used to increase. We cannot increase with we cannot increase the number of partitions with coalesce. Okay, but the problem here is, guys, in case of the repartition, we're having the shuffling. Clearly, you see, coalesce is not having any shuffle. There is no shuffle, because shuffling incurs additional burden on the cluster. So as to avoid that particular thing, and I want to perform some kind of the optimizations, I can make use of my coalesce property. Okay, but here, what is the limitation, guys? What is the limitation? The limitation is like this: I can only reduce the number of partitions with coalesce. Okay, but there is one alternative for this, guys. If you want shuffle with coalesce, okay, and then you can increase the partition because this is no use actually. Though it is supported by Spark, uh, until you are explicitly mentioning, okay, it's okay for me, even in coalesce also, if it is shuffling means, then it becomes a repartition actually. Okay, now let me show you what I am talking about because these points, once you see the implementation, then you can easily realize. Don't worry, guys. Just now I'll clear the aspect without any problem. Okay. Now, as usual, just we are importing the Spark session and we are running into the optimization. And I want to load this address data, whatever we have stored earlier. Now, initially, guys, in our AWS cluster, if you observe, if I am making use of my uh, ARM cluster, like master ARM, it becomes 200 actually. The number of partitions become 200. However, I am using the community cluster here in Databricks, and my number of partitions are 2. It's perfectly all right. Now, this functionality shows that maybe if you are, let me run through. Okay, so this orders RDD1. Okay, so this particular RDD1 may be containing some number of informations. So let me pick up how many are there in RDD. These many records are there, friends, 68,883. Now, if I want to specify how this particular data is distributed into my partitions, that is understanding like these many data items are there. I'm having only two partitions, then how I am distributing. So this particular functionality helps us, guys, return an RDD created by coalescing all elements within each partition into list. This GLOM, okay, this GLOM function helps us, okay, how the distribution happens, okay, how the distribution happens in each partition. Now you see this guy, almost equal number of the records were distributed to these two partitions. In the first partition, I'm having the 34,564 records. In the second partition, I'm having 34,319 records. Now, as I said, if I want to increase or decrease the number of partitions, now itself you have seen we are having the two partitions with us. Now I'm not happy with the two partitions. I want to increase the number of partitions. So for that I'm having the concept of the repartition. Okay. So what do you mean by this repartition is just to have a look on that, guys. Return a new RDD that has exactly number of partitions specified can increase or decrease the level of parallelism in this RDD. Internally, this uses a shuffle to redistribute the data. If you are decreasing the number of partitions, consider using the coalesce. See, even one single word is not wasted in this documentation, friends. It's like a Gita or it's like a Bible or Quran kind of thing for all our programmers, for all our developers, for all of us. See, I used to admire this kind of documentation, guys. It's really excellent. See the way they portray simple. Any member who is really practicing and researching on this kind of the techniques and understanding of this subject, he can straight away go to this documentation and he can venture that whatever the statement we have used with the diagrammatical and all those things to understand simply with the narration with the documentation you can see written a new RGD of course that has exactly how many number of partitions you want can increase or decrease the level of parallelism in this RGD. Level of parallelism in the sense here partitions internally. This uses a shuffle or redistribute. As I already we have seen, we are having idea about that. And if you are decreasing the number of partitions in this RGD, consider using coalesce, which can avoid performing a shuffle. If you want to decrease the number of partitions and if you want to avoid the shuffling, then only the possibility is coalesce. Okay. Now if you see this thing, I want to increase the two partitions into five partitions. Okay. Now I am getting this. How do I do that? Just RTD1 dot repartition. Automatically it becomes five now. Now, if you see the number of partitions, I'm getting five. Now, I'm interested. If I'm having the two partitions, then the way of distribution is like this. Each partition is roughly maintaining 34,000 change records. But now, how do I manage this thing? So 13,770 around all equally partitioned friends. If you see the repartition kind of the technique, and we have increased that partition from two to five, and we are making use of these five partitions so as to increase the parallelism. Now, based on these five partitions, one can easily achieve the appropriate functionality and whatever the activities you want to perform. It's perfectly proving that your parallel nature can be achieved. Likewise, we can make use of the convention of performing the task. Now, it is a time to decrease. I'm not happy with this five partitions. Okay, rather than two, rather than five, I'll take three partitions. Maybe I'm not interested to waste the memory and number of partitions. And moreover, without any shuffling, I can completely reduce my number of partitions with the help of the coalesce. Okay, let me show you the documentation. So your coalesce is something which is returning a new RGD that is reduced into number of partitions. So actually your RGD is containing five partitions. Now what I'm doing, I'm decreasing this number of partitions into three with the help of the coalesce property. Now you see get number of partitions three. And I'm quite interested to understand how these partitions are distributed. Friends, here the problem with the not problem the characteristic of this coalesce is because two or three partitions I'm having, it's practically what it does is some two partitions are having very nearest number of records, but your third partition is very less number of records if you observe. Okay, so the equal distribution is not there here. So according to the reduction of these number of partitions, because your coalesce is not shuffling anything, what it does is it is if you observe the diagram, let me go back, friends. Now it is very significant to go back and see the diagram. Now you see here. What it does is it is adding the bigger partitions. Okay, whatever the partitions, just it is combining the partition rather than shuffling. Directly, it is creating the new partition without any shuffle. Now you can realize easily that is the reason why these two partitions are having the more number of the records, whereas this partition is having the less number of the records. Okay, so this is not at all touch based by the corresponding coalesce, and it is only with the no shuffling option, it is performing the activity. Now I am performing exactly against to our discussion. Coalesce is not used for the increase of the partitions. But as a programmer, we need to try all the possibilities. We cannot believe on the documentation or something. We should see that thing evidentially. Evidentially, in the sense, what we are doing, just we are trying to increase the number of partitions. But according to the documentation given by the Spark, coalesce is used only for the decrease in the number of partitions. And if you want to increase the partitions, better you go with the repartition. Coalesce is strictly used for the reduction of the partitions. But still, I am trying. And what I am doing here, coalesce, I want to increase the partition from 3 to 10. So far, I'm having only three partitions. Now I want to increase to 10. So you see, nothing happened. Though I am insisting, though I am insisting, but still your coalesce by default, it is not raising the bar of 3 to 10. But there are always some hacking techniques. Na? What is the basic understanding of the coalesce, friends? Coalesce is a repartition technique where the number of partitions can be reduced with the help of the coalesce. And one of the default property of the coalesce is your coalesce is not shuffling anything. so that in a convenient, in a best way, Spark can maintain the appropriate data without any shuffle process. But if you are okay to shuffle the data, if you are okay to shuffle the data, then what should you maintain? I'm using the coalesce, and I want to increase the number of partitions as 10, but I want to mention shuffle as 2. That means what we are doing, coalesce plus shuffle, which is repartition, nothing but that. Because the programmer's mindset is a bit distinct, guys. Okay, we always strive for else condition only, not on the if condition. So we always go to the second way and we'll see how the things happens. Yes, of course, that is required because we have to see all the negative sides of the programming also. And coalesce, though it is only allowing the users or programmers to have to decrease the number of partitions, but at times there may be a possibility of you can use this coalesce so as to increase the number of partitions, provided you should explicitly mention your shuffle must be true, then which is very much similar to your repartition, because the only difference between no, two differences are there in repartition and coalesce. Repartition can increase or decrease the appropriate partitions, and repartition shuffle the appropriate details or input data. But whereas your coalesce is only used for the decreasing of the number of partitions, it is not using any shuffle mechanism. Now, at times, if I want to equate my coalesce property and as well as the repartition, a simple thing, you can use coalesce for the increase of the partition. Okay, and you can specify the provided if you want to increase the number of partitions with the coalesce property, definitely you should shuffle should be maintained as true. You have to maintain that shuffle as true. Now you see here, just you are maintaining that convention. Now it becomes 10. Okay, and as usual, now I want to see how my data got distributed equally all around 6,800 or 6,900 change. Like in 10 different partitions, my data is getting stored. Okay, so this is the way how you can perform the concept of the repartition as well as the police property. Okay, the story is not end here because we need to see that storage levels and all. Let me pick up some data with me. I'm having some data set, which is nothing but list of tuples. This is the data. Just what we are doing as per our requirement, we are creating the data frame with schema. Schema, as I said, which is used for the sake of maintaining the proper naming convention and type of the data related to this data frame. Now, initial I'm having the partitions as 8 and my records are also 8. Okay. Now I want to see that how my data got distributed. In these ways, my data got distributed, right? In number of records in each partition. Now, what I want to do is, as age is the criteria here, okay, maybe I want to see how many voters are there, something like that. Okay, the persons who are having greater than 20, I want to allow them to vote. Maybe the elections were there in our some kind of manager election or something like that. Okay, other than our general elections, where there are certain elections in our apartment or somewhere in a community kind of thing. So in that case, guys, they restricted to vote only the members who are having age 20. Now, obviously, your number of records becomes less because this 15, 18, 19, these three records are not scoped. But still, after applying this particular age also, my partitions become 8. Okay. So what I'm doing here is now I'm storing, okay, now I'm storing this outcome in a new data frame. And here also in my new data frame also my partitions are 8, but count of records are only 4. Earlier it is 8, friends, if you observe. Earlier my count is 8. Of course, it is understood. If I am applying any filter kind of the condition, definitely my number of records becomes less. Now what should I do? Then in that case, I am applying the repartition on top of this data frame and I'm storing in a new thing. Now you see the repartition, of course, you can use either repartition or coalescence because as we are reducing the number of partitions, it is always better to have the repartition. I mean, coalesce. Now you see, so but still, even after getting this particular storage, whatever the filter, only all four records are stored into one location. This is not actually our idea. Our idea is as we are reducing the as our data set got reduced with the filter condition, but still we are going ahead with these eight partitions, which is a waste. Data is less, partitions are more. Why simply? So just what we are doing here is even after observing this thing, I don't have any benefit of storing my data into these partitions. Now for that particular case, friends, you cannot directly mention the repartition in this way. Rather, argument you can give on the filter condition. Argument you can give on the filter condition. The filter condition is age greater than 20 members only. I want to pick up. So what I am doing here, repartition of the age. Now you see, I am not giving any number of partitions, whether that is four or eight. I am not specifying the number. Rather, I am giving this argument. Now you see the number of partitions only one. Accordingly, this particular thing is going to work out. This is the optimization friends actually. Reason behind it is roughly you cannot reduce or increase the number of partitions. Though you are doing that, sometimes your data set may not be equally distributed, especially in the filter conditions and all. In that case, friends, it is always better to repartition your data based on the corresponding condition. If that particular condition is populating more records, or if that condition is reducing the number of records, in either of the case, in either of the case, the Spark decides whether I should go with the one partition, two partition, or three partition. This is one of the best part in understanding of the Spark optimizations. Though explicitly the user having the capability of increasing or decreasing the number of partitions, but still Spark is having its own kind of the functionality to perform the logic. Okay, this is one of the important criteria. And one more thing, guys, here. Suppose if I want to specify the shuffling of the partitions. Now you see here spark.conf.get spark.sql shuffle partitions. It is giving us 100. So now what I'm doing here is I am setting my number of shuffle partitions as 100. So now if you see spark.conf.get of these partitions becomes 100. Now again, if you apply your repartition technique on gauge, now if you see the get number of partitions, still it becomes one. In that case, guys, there is one more possibility with the repartition. This is your number of partition three. Because I don't want to miss out, I don't want to place all these kind of the partitions into a single drive. Because though I'm having four or five partitions, still my age is storing in the last partition. So as to avoid that convention, just to explicitly mention the number of partitions along with the corresponding feature. Now you see it is becoming three. So at times these kind of possibilities are also a bit challenging for our developers. Guys. The reason is maybe I'm using the AWS cluster or Azure cluster on top of this. On top of that Azure, we are running the Databricks. Now it was observed by the administrator. Okay, some of the activities, some of the filters are acquiring more. I mean, more data is consumed. More data is consumed. So what we are doing here is, guys, just we are making use of the convention of repartition of the data. Just I need to maintain some environmental or by the default parameters, and I should set these kind of the parameters accordingly. I can manage these repartition kind of the technique. So though I am giving the repartition here, but still it is not distributing in a proper way. So as to avoid that thing, sometimes I need to handle the shuffle partition kind of the thing. After getting these kind of the convention only, I can able to perform the activity. So this is how you can make use of the convention of okay doing the things. And moreover, I need to show you this skill. 1 minute, guys, where I kept that. This storage level and all. I'll share with you guys soon. Yeah, cache and persistent. Okay, this is the thing. With this, after completion of this thing, we'll have a break. Okay. Now caching and persist already we have seen, which is something like so as to access the most frequently accessed items. Now, as usual, Spark session and then persistent cache demonstration. Just what I'm doing is I'm creating one RDD. Friends, you may have observed both in the repartition and coalesce, we have dependent on the RDD. Now in the persistence and cache also, we are dependent on the RDD. Remember one point, if a Spark context is there, if any memory relevant aspects are there, if any low level kind of the functionality we are doing, definitely you have to depend on the RDD. So data frame is a high level API where it is for the sake of performing some logics, transformations and actions. But whereas if you want to perform some memory oriented kind of thing, then RDD is the best possible way. What we are doing here is we are creating one RDD. We are creating this parallelize kind of thing where the whatever the data you are giving that will be parallelized and distributed to the corresponding RDD. This is display of the data. Now I am checking that whether my RDD is cached or not. Observe that friends, by default our RDD is not cached. That is what it is saying false. That is what we saying false. Now, what I mean to say is that this RDD I'm going to use many times. Okay, this RDD I'm going to use many times. So I'm checking that whether this RDD is cached or not. System is saying that your RDD is not cached. False. Now, what should I do? I can make use of the persist. Okay, the method I'm using so as to persist my or so as to cache my RDD is persist. Okay, so now if you refer this particular persist kind of thing, which is making sure that I can make use of the specification, okay, and accordingly I can specify the appropriate caching. Now RDD1 dot persist. Now it becomes the kind of cached mechanism. Now you see RDD1 dot cache. Yes, true. Okay. Now one more important thing, guys, here we have seen some storage level actually. So what is the default storage level? The second is true means memory only. Second is true means memory only. So whatever the RDD I am using and I am persisting, all I have persisted and where this particular thing got stored. Now you can see here guys, the default storage level is the memory only. Okay, just I can mention, this is the default storage level, which is memory only, which is memory only. That is the second argument is true. The second arg is true. Okay. So likewise, just if you are making use of that second argument, okay. So now I can say my default RDD storage is second. That is true. Memory only. Now I want to persist. Okay, I want to persist my storage level to memory and disk 2. If I am saying memory and disk 2, friends, what should I do? Memory and disk means this should be true, second should be true, and disk 2 that too. This becomes true actually. It should become true. Now, if I am saying that, it is saying that your storage level is not defined. And if you want to get more information, you have to use the storage level. So for that purpose, guys, in PySpark, I'm having a module called storage level. So just I can make use of this particular storage level. Now, what I'm doing here is, guys, just I'm mentioning that my storage level is memory only. My storage level is memory only. Now, if I'm doing so, if I am persisting storage level memory only, it becomes true. It is the default storage level. Whereas if I want to persist my storage level, something happened guys here. That's what it I am unable to run this. Yeah, now it is running. Error running command level. What is that command level? Okay, don't worry, no problem. So now our understanding is this thing, guys. Actually, we are again creating the RDD one with these parallels. Now I am doing RDD, and one more important thing. Again, you have to create. Again, you need to create RDD to change the storage level. Already created RDD, you cannot change. So again, that is the reason we are creating this RDD, and we are mentioning that memory and disk too. This memory and disk too, what it does is it is providing us just you can make use of the memory as a second as true, disk first as true. That means true comma true, and last statement whatever we are having that should be true. Okay, so some problem it seems, guys. Storage level is not defined. Just now we have defined. Na? Okay, so run. Yes, and then now again I'm running the default storage level. And if you want to pick up this thing, cannot change storage level because already we have created. Now again you need to create. That's what I said. Again I am creating a new thing. Now I want to assign a new storage level. That is memory and disk. Done. And now you get the storage level. You can see first two things are true and this is true. Okay. Now this RDD is cached. Yes, it is cached. Now it is always not good practice to cache many RDD strings because if I am keep on caching the all RDDs, I may not have the memory for the new things. So for that, I am having the unpersist. Unpersist is a mechanism where I can remove the caching of the RDD, and you can run through and it is become false. So this is the way how you can perform your cache and persistent mechanism queries. Maybe for the first time, as the members who are having the knowledge on operating system or computer organization like caching and persistence, they may be getting clarity on that. But don't worry, the remaining members also just you go back and review the recording once more, make a note on that because I don't know how many of you are taking the running notes. Because sometimes it is always better to note down the aspects, and especially in the today's session, all the optimizations we are talking about. So just to label them and try to maintain the rapport with these kind of the concepts because though whichever the programming language we are using, the ultimate goal is to come up with some kind of analogy friends like in a optimized way I should complete the task. Okay, and I'm having some other thing friends. Broadcasting is pretty simple. Reusability, suppose I'm having these abbreviations, and with the help of this particular broadcasting kind of variable after creating this broadcast, I can suppose this is the scenario, guys. Sometimes I want to maintain a convention of some of the members we are giving some comp off. Maybe for Uma we are giving Monday comp off. For Harish we are giving Tuesday. For Bala we are giving Sunday. And for Vedant we are giving Tuesday. Something like that. Devraj and all. And these are all guys working for different locations: India, US, UK, US, like that. Now, in these kind of the conditions, I am not ready to elaborate that Monday, Tuesday, complete day. Just I am using the labels, and whenever there is a requirement, then only I want to elaborate the labels. For that purpose, I am making use of the broadcast variable, and this I am sharing with you guys. Just have a look on that. This entire data and coding because this is a combination of the